I welcome you all for this presentation. In this presentation also we are continuing the substitution techniques, and in this presentation we are going to discuss about one of the substitution techniques, that is the affine cipher. This is the overview of this presentation: introduction to affine cipher, then encryption and decryption of affine cipher, followed by summary of this presentation. In the last presentation, we have discussed about the monoalphabetic substitution cipher. So all are aware that what is a monoalphabetic substitution cipher. So here we are replacing one character with another character. That is, we are substituting one alphabet with another alphabet. That is the monoalphabetic substitution cipher. This affine cipher is also coming under the category of monoalphabetic substitution cipher. And mainly this affine cipher works on the principle of modulo m. Modulo means that is the length of the alphabet used. Here m, that is the length of the alphabet used. Mostly m here is 26 only. Say for example, if you are having a modulo 7 mod 26, then answer is 7. Suppose you are having 0 mod 26, then answer is 0. If you are having minus 1 mod 26, then what you have to do is, it is minus 1, but minus 1 there is no alphabet, corresponding alphabet for this digit. So what we need to do is, always the number, the modulo result must be within 0 to 25. So what you have to do is, in this case, minus 1 plus 26 is equal to 25. This way we have to find out the modulo operation. So by performing a calculation on the plain text letters, we are enciphering the plain text. That only we know the encryption process. So let us see how this affine cipher is working. So this is the encryption process. Here we are transforming each of the letters in the plain text alphabet to the corresponding integer in the range 0 to m minus 1. Here in our case it is 0 to 25. And the encryption process for each letter is given by E of x, that is encryption of x equal to A into x. Here what is x? It is the plain text plus B mod m. Here this A and B are the key of the cipher. So always whatever the encryption we are performing, there is a key. So here the key is A and B. And here what we are doing is, we are multiplying the integer value for the plain text letter by A. Then we are summing up that the product with B. Then we are finding at the modulo operation. That is, modulo means we are taking the remainder when the solution is divided by m, or we are take away the length of the alphabet until it is less than the length of that particular thing. That is called as the modulo. So I already told you how to find out the modulo operation. So encryption is very simple. Here A into plain text plus B mod m. Here A and B are the key in affine cipher. Let us see one example. Here encrypt the plain text affine cipher using the key A equal to 5 and B equal to 8. First what we need to do is, we have to find the corresponding integer value of each and every alphabet. So here we are having for A, what is the corresponding integer alphabet? It is 0. And for F it is 5. For I it is 8. Likewise we have to find out the corresponding alphabet. Then only we have to apply to that equation. That is that formula. So with the integer values of the plain text letters found, the next step is to perform the calculations on those values. So here what we need to do is, we are having A value as 5. You know that A equal to 5 and B equal to 8. So we are having AX plus B, that is 5x plus 8. Then we are ensuring that all the answers are calculated mod 26 and convert the integers back to the ciphertext. Let us see this one. This is the plain text, that is the affine cipher. Then we are writing the corresponding integer representation of each and every alphabet. Then we are finding out the value 5x plus 8. So here you see that 33. So we have to perform 33 mod 26. So 33 mod 26 is 7. So you see 26 plus 7 is 33. So 33 mod 26 is 7. So likewise for 48 we have to do, that is 22, 73 it is 21. Then after getting the mod value we have to replace the integer with the corresponding alphabet. So now we got the ciphertext. For the affine cipher plain text we are having the ciphertext IHHWVC then SWF or CP. This is the method to find out perform encryption operation using affine cipher. Next, the decryption process. We all know that decryption is a reverse of encryption process. So here we are performing the opposite or inverse function on the ciphertext to retrieve the plain text. So what we are doing is, first we have to convert each of the ciphertext letters into their integer values. Then we have to perform the calculation, that is d of x equal to c into x minus b mod m. Here one thing you have to notice, the sender knows the key a equal to 5 and b equal to 8. Likewise, the same key value is only known to the receiver, that is a equal to x, 5 and b equal to 8. So how we are calculating the decryption, or how we are performing, the receiver is performing the decryption operation here is, we need to compute C. What is C? It is a modular multiplicative inverse of A. So in this affine cipher we are just guessing the multiplicative inverse, but there are many methods to find out the multiplicative inverse, and here we are, the maximum value is 26 only, so it is very simple to find the multiplicative inverse. But in general case, if you are taking very large prime numbers, in that case this method doesn't work. So we have to go in for some other algorithm. So we will be, in the coming presentation, we will be discussing how to compute the multiplicative inverse using some techniques. So here how we are computing the multiplicative inverse means, A we know key, C is a modular multiplicative inverse of A. So A into C equal to 1 mod m. Always if you multiply some value with this A, we must get the answer as 1 mod m. So that value is the multiplicative inverse of A. So here C is a number such that when you multiply A by it and keep taking away the length of the alphabet, we have to get a 1. So let us see an example. The same example we are continuing in the decryption also. Here you see that decrypt the ciphertext, this one. This is the ciphertext of the plain text affine cipher using the key A equal to 5 and B equal to 8. So here the first step is we have to find the inverse of A. If we find the inverse of A, then only it is possible to apply it, right? C into y minus B, we can apply it, mod 26 we can find it. So here we are finding the inverse of A, which in this case is 21. How means 21 into 5 we are getting, that is C into A equal to 1 value, which is equivalent to 1 mod 26. So here C value is 21. So we are performing the inverse calculation on the integer values of the ciphertext. So in this case the calculation we are doing is 21 into y minus 8. So then after performing the modulo operation, we have to take the corresponding, we have to match or map the integer to the corresponding alphabet, so that we are getting the plain text. Here the ciphertext is given. Then we are writing the corresponding integer representation of the ciphertext characters. Then we are writing C into y minus B. C is the multiplicative inverse of A, the key, I minus 8. So here we are getting the negative value, minus 21. See here, minus 21 mod 26. So how to compute it is minus 21. So minus 21 plus 26, which is equivalent to 5. So only here we are getting a 5 value. The corresponding this 5 is mapped to F based on our table. So this way we have to perform decryption using affine cipher. So in this presentation we discuss about introduction to affine cipher, then encryption and decryption of affine cipher. The next presentation we will be discussing about polyalphabetic cipher. Thank you.